Hi there. Now in this video what I want to do is introduce you to equations of lines and the form it takes. And to do this I'm just going to take this particular graph. Let's say we look at the equation y equals 2x plus 1. And if we wanted to plot this graph, what we do is we form a table. A table of values, say something like this, where x in this example goes from -3 in steps of 1 unit all the way up to 2. You can pick any range that you like. I'm just going to try and fit it on this piece of graph paper here, which goes from x equaling -4 to 3. So if we're to work out what the corresponding y value would be for each value of these x's, then all we need to do is substitute each one into this equation here. So when x equals -3, we've got 2 times -3, which will be -6, plus 1 is going to give us -5. And then if I substitute -2 into here, 2 times -2 is -4, plus 1 is -3. For -1, 2 times -1 is -2, plus 1 is -1. Now when it comes to 0, 2 times 0 is 0, and we're just left with y equaling 1. I'll put this one in red. You'll see why later on. Last two to finish off here. When x is 1, 2 times 1 is 2, plus 1 is going to give me 3. And then finally, when x is 2, 2 2's are 4, plus 1 is 5. Now if I plot the coordinates on the graph paper for the first one, -3, -5, if we go -3, -5, it's not on the graph paper, it's a point down here. We'll leave that one. Let's take the next one, -2, -3. So -2, -3 is this point here. Then we've got -1, -1. -1, -1 is that one. And then we've got 0, 1. I'll do that one in red. 0, 1 is this one here. And then we've got 1, 3. 1 across, 3 up. And you can see these points are coming out in a straight line. And then 2, 5. 2 across, 5 up. It'll be up here. It'll be in line with these points, okay, but just off the graph paper. So I won't plot that on. And if I was to join these up with a line, we'll get something like that. Y equals then 2x plus 1. Now I've done a selection of points here in the table, but I could have taken other points. We can see that any point on the line would satisfy this equation. For instance, if I said x was a half, 2 times a half would give me 1, and 1 plus 1 would be 2. So when x is a half, y turns out to be 2. And you can see that would be the case here looking at the graph. When x is a half, the corresponding y point would be 2. So although I've just done a selection of the points, any point on this line would satisfy this equation. Now let's look at another graph. Let's say we look at the graph of y equals, say, -x minus 3. And I'll draw up a table of values, x going from -4 to 1. And we'll plot the corresponding y values for this. So when x is -4, we're going to have -4, which will be +4, and then -3 will give us 1. Okay? When x is -3, we'll have -3, which will be +3, and then minus another 3 will be 0. For -2, we've got -2, which is +2, minus another 3 is -1. For -1, we have -1, which is 1, minus another 3 is -2. And when it comes to 0, I'll do this one in red again. When x is 0, -0, well that's 0. And then just -3, that's going to be -3. And finally, when x is 1, we'll have -1 minus another 3, which is -4. And if I plot these points on the graph paper, minus 4, 1 is going to be this point, minus 3, 0, that point there, minus 2, minus 1, this point here, minus 1, minus 2. Can you see how the points are coming out in a straight line again? And for 0, minus 3, we'll do that one in red. And lastly, for 1, minus 4, it's going to be down here. So if we join these points up now, we've got a line with an equation y equals minus x minus 3. Now, any line has a particular form. That form is often referred to as y equals mx plus c, m and c being constants. And you can see in these two examples here, we've got that form. Here we've got y equals a constant, 2 in this case, times x, plus another constant, c, which is plus 1. In this equation here, we've got a constant, m times x. That constant is minus 1, which is multiplied with the x. And then we're adding the constant c, we're adding minus 3. So c would be minus 3 there. Now, something else happens, which I'm just going to show you. If we look back at y equals 2x plus 1, notice how for every 1 unit that we increase the x, okay? Let's see what happened to the y values. Going from minus 5 to minus 3 was an increase of plus 2. Going from minus 3 to minus 1 was to add 2. And then minus 1 to 1, it was to add 2. And it's to always add 2. 1 to 3 is to add 2. 3 to 5 is to add 2. So, and so on there. And you can see this from the graph. Notice that for every 1 unit we move across in the positive x sense, hence the arrow here, notice how y increases by 1, 2 units. Move 1 across again, y increases by 2 units. 1 across, y increases by 2 units. And this is referred to as the gradient. And do you notice that this 2 here happens to be the number in front of the x? Is this a coincidence? Well, let's just test it on this graph here. When we look at our values for y, as x increases by 1 unit, y goes from 1 to 0. That's going down by minus 1. Going from 0 to minus 1, that's going down by 1 unit. Minus 1 to minus 2, down by 1 unit. In fact, it's going down by 1 unit all the time. And that agrees with what we got here. We've got minus 1 times x, which agrees with this number. And when I look at how it turns out on the graph, you can see that for every 1 unit we increase x, y drops by 1 unit. 1 across, y decreases by 1 unit, and so on. So what we've got here is the gradient. The gradient for this graph here is negative 1. It seems to match up with the value in front of the x. And also, let's have a look at this value that I've put in red here. Do you notice this 1 is the number on the end here, and minus 3 is the number on the end here? It's when x was 0. And when x is 0, it turned out to be the point on the y-axis. And these points here are called the y-intercepts. So if I break this equation down, I'm going to color code it, okay, just for the moment, okay. We've got y equals, and this 2 here is the number we've got here, the gradient. And then we've got, that's multiplied with x, and then plus 1 was the y-intercept, the number that we got here when x was 0. So we'll just write that in as plus 1. it works exactly the same on this equation here for a straight line. We've got y equals minus x, but that's the same as minus 1 being multiplied by x. And then the minus 3, well, that's the y-intercept, the value we got when x was 0. So we'll just put minus 3 in there. So hopefully that gives you a quick illustration of what these values m and c are. Let's just add to that. M is the gradient and c is the y-intercept. And this is an important form then to remember when it comes to the equation of a straight line, y equals mx plus c. Now just to strengthen that, I've got a few questions here, 3 questions where I want you to find the gradient and the y-intercept for the following lines. First one's very easy, then they get slightly harder. Certainly have a go at these. I'll give you a moment just to pause the video. When you come back, we'll run through the answers. Okay, welcome back then if you had a go. Well, for the first one, y equals 3x minus 2, this is in the form y equals mx plus c. So I can see that m, the number in front of x, is 3. So we can see the gradient, we'll just put m there, the gradient is 3. And the y-intercept, the c value, would be minus 2. We're adding minus 2. So c would equal minus 2. If I had to sketch that line, it would look something like this. Okay, I'd have my x-axis, my y-axis, and then it would cross the y-axis at minus 2, and a gradient, a positive gradient of 3. So I would expect that to be a line that is going something like that. Okay, I hope you can see that. That point there where it crosses the y-axis would be at minus 2. And for every 1 across, I would expect the line to rise 3 units. Okay, now for this second one, you've got to take a lot more care. It's very easy to make the mistake and think that m is 8 and where it crosses the y-axis, the c value is minus 1. It's not. And that's because we've got a 2 in front of the y. Remember, it's just got to be y equals. So what we've got to do here is divide both sides by 2. And if we do that, we therefore have y equals 8x divided by 2, which is 4x. And then minus 1 divided by 2, well, that would be minus a half. So what we've got here is that it follows that m, the gradient, is 4. And where it crosses the y-axis, the c value, will be at minus a half. Okay, so it'll be a line similar to this, only crossing at minus a half, a bit steeper. It's got a gradient of 4, so for every 1 across it would rise 4. Now for the last one, number 3, well, with this one we've got to totally rearrange this so that we get y the subject. And so what I'm going to do is to subtract 5x and add 8 to both sides. So we get 4y equals minus 5x plus 8. But we still got to divide both sides by 4, so we get y equals. So dividing both sides by 4 gives us y equals, and then we'll have minus 5 over 4, minus 5 quarters then, x, and then 8 divided by 4, well, that's going to be 2. So from here, it follows that m, well, that's the gradient, and it's going to be minus 5 quarters. And c, well, that's going to be 2. So what we'd have here is a line sloping in the negative sense, crossing at 2. So it'll be a line up here, sloping down like that. Okay, well, thanks for listening, and I hope it's given you some idea on how we go about using y equals mx plus c as the form for a straight line.